Karen from... Yes, that reminds me. So just before we start, just a couple of housekeeping rules. So if you could all switch off your microphones and videos, which I think you've already done. The meeting is being recorded and we put it on our website afterwards, so you can go back and have a look. I will also email some links to all of you after the event, helpful links that Roger is kind of referring to in his presentation. So without further ado, I'll introduce our speaker. Today is Roger Curtis, Technical Research Manager at Historic Environment Scotland. He is a chartered building surveyor by trade and has extensive experience with historic buildings. And today is talking about traditional mortars. And I just hand over to you, Roger. Thank you.
Super. Well, thank you for the introduction and the chance to speak at your session this lunchtime. I've probably got about 40 minutes and then some time for questions and discussion. I've called it Traditional Mortars, Adaptation, Publications and Projects. And the adaptation is deliberate because we're finding that it's quite often not so much the mortar that people get wrong, it's the conditions around the mortar and adaptation to climate change, which in Scotland generally means more rain, really, means that the building geometry on the outside, the design, the drip detailing needs to be right, otherwise the lime doesn't really have a chance. So that's why I've consciously put in adaptation. In the presentation, there are several links to publications that we've produced as a result of some of the work. And then I'll be covering a few of the projects that we've been doing over the last 5 or so years, mentioning the good bits, but also the bits that didn't go quite as planned. So let's crack on then. So traditional mortar, which probably a few years ago we tended to call quicklime or hot mix mortar. But what we really meant was traditional mortar. And I'm going to restrict this to lime at the moment. There are other types of mortar. There is clay mortars and there is also earth. But I think probably for the purposes of today and what you're likely to be experiencing, I'll stick to lime-based mortars. And perhaps just to summarize what you obviously know already, but the general sequence, which I'll illustrate and use to pull out various points about it in the presentation. So we're talking about extraction of the original material from which you get your quicklime. Now that can be limestone from a quarry, or indeed it can be some other form of calcium carbonate, which in parts of Scotland, particularly on the west, is actually from shells, seashells, which makes an excellent mortar. You've then got the burning aspect of the lime, and Scotland is rich in lime burning areas where obviously where the lime was, and quite extensive remains of lime kilns and the processing that went with it. Like everything, it's lime burning is a fairly complex process, but once you've got the principles and a bit of experience, it's not as difficult as it looks. Then you slake the material, you add water, which gives you your putty or your ingredient for the mortar, and then you add the sand and maybe other things, and then you use it. So that's the general journey. Very different probably to a modern mortar where the guys on site just get a bag and add some water and some sand and off they go. So where does it start? Well, I discussed quarrying and removing the material from the ground, normally a limestone, and that can be quite varied in its actual appearance. It can be very grey, it can be very hard, it can look a little bit like a sort of dark grey marble, and you're not quite sure what it is. Or indeed, if you're in other parts of the country, particularly down in Kent, you can get chalk, which is obviously bright white. So this material is taken to a kiln, and this is a historic example, probably dating from the 1780s or so. And the lime material, you can probably see my mouse just here, is put into the opening at the top, which is essentially a conical shape behind this masonry, going down, circular cone going down to the draw point, and you'd layer stone and the burning material, quite often coal, but can also be wood, or in the Western Isles or other parts of Scotland, that can be that they use peat too. It's lit at the bottom and then burnt. Now, the exact detail of this I won't dwell on too much, but essentially the fire burns through and you keep adding layers on the top, layers of fuel and layers of lime, and you draw the material out the bottom quite hot. That's a continuous process, or indeed you can do it as one-off. So that's when you see these in the countryside and on the edge of cities, that's what you're looking at. You're looking at a lime kiln. Larger ones had 3 openings or sometimes more than that. And the good example of that is the lime works at Charleston. Here is my colleague, Chris McGregor, an architect with HES. Been working at HES for a very long time now. And he's just about to light the draw point of a reconstructed vernacular kiln at Castle Bay on Barra. And you can see the sods of peat have been piled up, and in amongst that is a lot of shell, various types of seashell that they've gathered. In this case, it was byproducts from the seafood industry. And that was burnt in that kiln overnight. And inside a kiln will look a bit like this. The temperatures vary, but we're talking sort of over 1200 degrees centigrade. That progresses for a period of time, and the judgment of when something is burnt at the right temperature, at the right speed, is something that the kiln operator acquires over time. You can burn too much and you can burn too little, overburnt and underburnt. If you burn much more, you start getting harder cementitious type products, so it does affect the performance. When the limestone comes out of the kiln, it'll look a little bit like this. You can say, well, that doesn't look massively different to how it came in, and that's entirely right. So all that's happened here is carbon dioxide has been flashed off by the heating, has been expelled, and that is your quicklime. Most modern quicklime now comes in crushed to some degree, kibbled, sometimes as a powder, or indeed sometimes more or less looking like that, called lump lime. This kiln here is a demonstration kiln used with 4-inch concrete block that's set up and used for demonstration purposes at our training facility in Stirling. So that's your quicklime from limestone, and here you can see some of the shell that was burnt in that kiln and Barra. You can tell some of them look like scallop shells and other things. They've just started to add the water to do what we call the slaking. So that takes the cooked material, it slakes, it combines with the water to give you the lime putty. And quite often that is added, the quicklime is added to the sand in a forced action mixer of this type here, and you add the sand, and the slaking is done at the same time, generates a good amount of heat, and the mixer pushes that round. You'll notice it's not a bell mixer. You can use bell mixers for quicklime work, but you need to have quite a wet mix to enable it to roll around in the bell mixer. And then you don't really want your mortar to be that wet. So there's a slight sort of tension in equipment, but contractors can hire these forced action mixers at reasonable cost now. So there's not necessarily a reason to be limited to the bell mixers. And that will give you a material that looks a little bit like this, quite a stiffish constituency. It's not sloppy like an OPC mix is for block work, quite fairly stiff. Pale grey is probably the word, and it should certainly stick to your trowel if you turn the trowel upside down. So that's your sort of test. In constituency, it might be somewhere between margarine just out of the fridge, is that sort of stiffness. This mix has cooled a little bit. Generally, most people, by the time you finish putting it in the mixer, shoveling it around and getting it up there up on the scaffold or similar, it has cooled down a fair bit. There are discussions about whether you use the mix physically hot or you let it cool down. It doesn't seem to make a massive amount of difference, although there are plenty of opinions out there. So that's your kind of lime mortar, and the mixes for this don't vary massively. Generally, it is 1 quicklime to volume with 3 sand volume, and then normally for that about 1.5 of water to 2, depending on how dry the sand is. So that has to be judged of the moment. There will be variations with this, and certainly if your quicklime is coming from a more industrialized source, which is in fact where most of us get it now, it'll be a very pure quicklime, and it won't have the natural pozzolans and clays in the original limestone that give you a degree of hydraulicity. So there is quite a lot of discussion about hydraulicity and how much do you want, how much is good, if too much is less of a good thing. And we can pick up the themes of some of that at the end. But certainly the very clear evidence that Scottish traditional mortars were made with quicklimes, produced locally, invariably, but they all had some degree of hydraulicity. So a lot of contractors will add probably 1/4 or 1/2 of an NHL to the mix that I mentioned as a way of giving an initial hydraulic set to allow the work to stay stiff and to give some sort of ability to continue building at a reasonable level during the day, and a fairly quick set to protect from running water and indeed other factors. There are other additives that can go into this. We probably don't really have time for that now, but suffice to say that's the basic mix, and most of the analysis will give something that is actually pretty much similar to that. And then of course you build with it. So here's some reconstruction going on a small gabelet. This is actually down at Lochnaw Castle, down in Dumfries and Galloway. And you can see the colour of the mix and how it is put in the wall there. And this is obviously this gabelet's got a couple of chimney flues going through, using a local whinstone rubble for that one there. But having sort of give a quick outline on the mortar itself, I think we need to just consider what the lime needs to deal with. And people talk a lot about lime failures, and in my experience, you've got to work pretty hard to make a rubbish lime mix. Probably there's a modern habit of making them too weak. Historic mixes are possibly even stronger than what I've described, sometimes almost 1-to-1. But the main thing to remember now is Scotland is wetter than before, perhaps 60% more precipitation than we used to have in the 40s and 50s. And therefore the buildings of all types, historic buildings, traditional buildings, big ones, small ones, are having to deal with a lot more water. This is aggravated by a lack of maintenance, incorrect materials, and a fairly low skill level generally in many contractors. And we've lost an understanding of detailing, both at contractor level, but also at designer level too. And the failures I've seen have been when water is not running off a building, it is running down the building. So if you're putting water on the face of a building over and above wind-driven rain, which is fine, that lands and it dries off again. But let's say defective rainwater goods or skew copes on a gable that are not sufficiently detailed for the new conditions, you keep the water wet, it either doesn't carbonate, never hardens up, or indeed it spalls off in the coming frosts. So just a couple of images on this, and again, this is a building in just south of Edinburgh. And if you look on the right-hand side, you've got the gable. A lot of money has been spent on what appears to be a formulated lime render, probably at some cost, applied quite carefully, sort of lined out and sort of chiseled back, even done the coins and things, and the top half of the chimney stalk. But what they've completely failed to address are the skew copes. So the sloped tabling on the gable, and also the cope over the chimney. And the lack of those two details means that the face of this material is not shedding water, it's just getting water run down it. And you can see the concentration points. And in fact, it's coming away in sheets. And it's also showing up as defects in the profiled gutter there, which is a relevant but maybe separate discussion. And that chimney head has also got a completely ineffective elephant's foot on the top, just running water back into the can there, ensuring that chimney head stays wet, freezes, and spools off the material that the client here spent a good amount of money putting on. I've summarized this in a quite sort of cheap and cheerful diagram here, showing the good side and the bad side, and some of the indicative things that we should be thinking about, including roof drainage and below ground drainage, which is often missed. Many inquiries about dampness in buildings, and my first question is always, what's the below ground drainage situation? And invariably that has not been addressed before quite an invasive series of treatments have been proposed. But that's a different topic. So let's hold that image in your mind. Please don't feel you have to read all the words. You can perhaps refresh with the circulated presentation later on. I know it's a small cottage, but actually this applies in principle to much larger structures, and it's the gable end that always gets the damage. And in the past, they were quite cunning with detailing. I touched on things, and it may not always be possible to project the skew copes wide over the plane of the front elevation or the gable. And in this case, they put a channel just shy of the outside edge there to prevent dripping down the face and to keep what would have been some form of render or covering on that stone from staining. Obviously, a very different approach has been taken with the masonry on this building in later years, and I think you can see those joints are certainly hungry, and water will come through those. But the point of this image is the delicate cut to give the channel to keep the water off the face of the mortar on the front gable. And in other countries, they've possibly been a little bit ahead with what I might call climate change adaptation and the detailing that goes with it. This is quite a significant landmark in Stockholm, where at intervals along the height of this quite tall tower, they've put in these really quite significant drip trays, if that's what you can call them, formed in copper, which is a very traditional material in that country, which will actually probably go green eventually, depending on the conditions in the city. But the main thing here is to show that you tall buildings or buildings that catch the wind and the rain do need to shed the water at stages down the elevation. And as I indicated, a very strong tradition in mainland Europe for doing that. Even in quite dry parts like Munich, you see this done as part of the 1950s reconstruction work. Anyway, I'm digressing from mortars a little bit. So just some thoughts on the framework in which we're operating when we're thinking about mortar work. This, for probably most of us, is renders or probably pointing more often. We need to match what was actually used. We do it very obsessively for stone, and we do mortar analysis very carefully. But quite often, what is actually used as a result at the end of that is sometimes a little bit different. And that's partly to consider the factor of authenticity and like-for-like replacement, but probably most importantly is the technical suitability. We want that mortar to be handling the vapor, the water in that wall in a way that allows it to disperse, and generally disperse outwards. That's our objectives. And if you get the technical suitability right and its equivalence with the existing mortar and to some degree with the stone, you've gone quite a long way to getting your elevation properly sorted, assuming you've got your drip detailing and your weathering correct on the upper parts of the elevation. It's also about craft skill and empowerment. I don't think that in building conservation we should be giving people bags and telling them to add water and saying that that is some sort of knowledgeable tradesperson. They're fully capable of configuring, batching up and using a traditional mortar. We just have to have the confidence to let them be confident and to get the details around the mortar correct so it works. We also know that if we get the mortar right, the building is more resilient. It is able to shed that extra rain and then recover afterwards when the conditions change. And let's also remember that many charters talk about appropriate like-for-like replacement. This is not unwritten material, and indeed Historic Environment Scotland principles for conservation tell us to do this. So there's many reasons for getting it right, and the main one I would argue actually is technical, because if we get it technically correct with a compatible appropriate traditional mortar, we're much better chance of our work staying there and doing a good job for the client and the building. There are probably quite a few outcomes from that: contracting, the skills, and I think that is a matter possibly of judgment. And actually, a good contractor can adopt new skills in this without too much difficulty. Design and detailing, absolutely. And we also must accept that a modern mortar we make will never be exactly the same. There's a few questions still which we can progress later on. And I would argue this cannot be about convenience, because if that is the case, where do we stop? So the HES position is we slightly hold the line on traditional mortars made with materials more or less which they would have had back in the day. And really, to help flesh out some of these points, we've configured a series of technical papers over the last 4 or 5 years which describe the evidence, the background, why we're sort of saying this, and then a series of case studies to set out what has worked. And indeed, in those case studies are bits that have not worked, but I'm hoping that you can learn from that, and that's of use, because they were pretty basic errors. They just happen in projects, as we know. Sometimes that's how the cookie crumbles. So that's some sort of background musings, and very happy to pick up some of these issues at the end in questions and discussion. And here's probably one of my sort of stepping off points, perhaps an objective for us. Maybe in time we would have worked out the mortar arrangements that gave us material that's as durable as this. So this is Ormaclit House on the south coast of Skye, the south end of the island, exposed to the southwest. The building was built in 1705, and then for various reasons it was unroofed and abandoned in 1715. So here is an elevation, or several elevations, with a lime mortar covering that has not been touched since that time. And particularly on the return angle, you'll have to admit that that is a pretty good survivor. And if we can achieve this durability with materials that we can use now in conservation, I would say we're doing very well. It's worth looking at this in a little bit of detail. This material, this render, is distinct from modern habits in 2 ways. Firstly, the quicklime is almost definitely a shell-based quicklime. So those shells we saw being burnt in the kiln at Barra. And secondly, it's quite a thin layer, so it doesn't hold a huge volume of water. So it doesn't have to. It is less vulnerable to frost damage because it dries out quicker because it's thinner. And interestingly, it's on quite a hard stone. Renders like this tend not to survive quite so well on sandstones. So if you get your mortar right, you get the sticky right, if that's a slightly unscientific word, you will get extremely good durability. So when people say to me, I've got a building, it's by the sea, I need to have a very hard cement to deal with it, I would suggest that this image of a historic render would perhaps suggest that if we got our historic render ingredients right, we could replicate that durability. So I don't want to dwell on it, but I think these are quite important points to get out. And it's worth saying that the technology, the habits, the construction, the traditions that went into this building are probably what would have been extant, certainly in the west of Scotland and probably over most of the country for the previous 300 or maybe even 400 years. So this is almost the sort of the end of the sort of vernacular traditional journey before classicism and other forms of architecture became dominant. Although, of course, the technologies did still more or less stay the same. So here are the documents that we've produced that I'm really here to try and shout about and perhaps get your eyes into some of them. So technical papers 27 to 32. So the microstructure and performance. So this is all about the ability of the wall to shift water and water vapor, liquid and vapor. And this is about a property of capillary activity. That's really what we're after. Obviously vapor, yes, but capillary active. Specification, modern examples. So number 29 is talking about what has worked well in recent practice from the 1990s onwards. And in that, it does look at areas of failure and it does consider why they might have happened. And generally, it's water in the wrong place up to a point. We were hoping with technical paper 30 to get some magic voodoo secret ingredients that would transform our understanding and give us endless opportunities for the building that I just showed you. But in fact, the references, partly because of trades did not write down much detail, and the detail that we did have in historic projects is mainly about cost. So it's about King James paying for X carts of lime for the palace at Stirling Castle, but it doesn't. Haven't really managed to find Master Mason Samuel, how he instructed his team to put together the mortar, because that was implied and implicit knowledge among the trades and the guilds at the time. Technical paper 31, which is really perhaps looking at other examples of ormaclit, where you've got historic examples of lime surviving often against all odds, but in an unchanged sense, so that we know that we're looking at something that was more or less as it was when it was done. Many good examples from the late 19th century right back to the 12th and 13th century, where you have extraordinary survivals of material due to shelter or accident or sometimes burial. And then more recently, technical paper 32 is the analysis of the data that has been, or the analysis of the samples that were put to the Scottish Lime Centre and then have been recorded. And Claire Tawney from HES and Anne Schmidt, who's in my team, crunched the numbers to give a quick overview of what historic mortars tended to look like. And it's no surprise to note that from the sort of 16th to 18th century, they were more or less quicklime based. And then by the mid-19th century, you started to see hydraulic limes gaining in prominence, but mainly in industrial or civil applications. So quicklimes continued to be used in domestic buildings. Often it was referred to as above the ground for air limes, and then below the ground for hydraulic limes. And certainly a long history of hydraulic limes being used in marine structures, lighthouses and things. And all the Smeaton project and all that stuff that you probably know about from early work with Historic England is referring to that type of thing. So just moving on quickly, what do they look like? Here's a couple of front covers. David Wiggins is one. We did a scanning electron microscope image, and then representative covers which give you a flavor. So this is what they look like. This is the new design template for HES, and you can see some later work. That's a project in Fife, and the representation of masons actually found in Jedburgh Abbey, as it happens. So that's the literature. What did people say about it? And in the literature one, we've tried to summarize where such historic evidence on the detail of lime construction exists. We've tried to sort of summarize it or catch extracts from it so people can look through and just get a feeling for what's there. It's amazing, often you can learn more about historic building practices from illuminated manuscripts and religious tracts where they describe in pictures the construction of early buildings. And sometimes actually that gives you a better sniff as to how things were done than 3 carts of lime and 5 carts of sand. Although from that, Nigel Copsley has sort of inferred an indication of mixed ratios as well. Later ones then, 31, this is about the renders. Cushmore Castle, this is the property in care just off bottom end of Barra. And much of the render that you can see on that building certainly dates from no later than about 1720, when the building was abandoned. It did have later repairs as part of its 19th century consolidation, but no, 20th century consolidation, but they're very limited and it's fairly obvious where they are. So quite a good survivor there. And then the final one is the sort of the data crunching on the numbers. That image there on the chapel shows some extraordinary survivals from a pre-Reformation building that hasn't really been touched since. And so by way of applying all this on the ground in what you might call pilots to see how this material worked, we did a series of pilots, and I'll rattle through some of these quite quickly with some key points that have come out at the end. So the first one then, and probably the one I reach back to most often, Sandhar, category B listed building in Shetland, approximately 1760. It's had a whole range of interventions over the years, and probably in the 1950s it had a cement render on the gable that you're seeing, and progressively that resulted in a wetter wall and then internal conditions, with the rooms really becoming virtually unusable. So we're approached by the architects who'd been commissioned by the client, and we supported them with a very sort of what you might call restrained tradition approach, removal of the cement pointing, repointing in a gauged lime mix, much as I described earlier, and then a very thin hull, single coat, and then several coats of lime wash. And that's what you're seeing in this image on the left. The significant thing here is we address the chimney quite aggressively, and that's one hell of a cope sticking out like that. That's not what it had in 1760. So LBC, listed building consent, was needed for that, but we felt that was necessary to cast a good drip. We didn't do anything to the skew copes, which you can see there was a few modest repairs, but what we did make sure we did was the lime wash was pretty generously applied, so that all the tiny cracks and the little fissures and things that the best eye in the world will not allow the trowel to reach are filled up and carbonated through. So you have a kind of healing patching layer to address very small areas of quite understandable oversight, or even maybe a little bit of shrinkage, because our aftercare can never be perfect. You're putting thin layers of lime onto this wall, and as we know, keeping that moist while the carbonation and the curing happens is part of the trick of the aftercare. Of course, when things were built from scratch, we're fairly certain from recent surveys that the hull and the finish was smoothed off more or less as they went up the building, and that ensured that you had a direct capillary connection with the reserve of water in the wall core going to the outside. So that kept it moist to allow curing and carbonation to happen over a very extended period. And of course, when you're repointing now and applying surfaces to all the buildings, you don't have that reserve of moisture in the wall. So quite rightly, we do spend a lot of time fussing about with Hessian and spraying and trying to get the conditions right to allow that that material to cure and carbonate at the right over the right time scale. And again, if you get your mixtures right on a good warm series of days, it should certainly take a press and a scrape probably within less than 24 hours. And certainly after 3 or 4 days, you're looking at something that's pretty much dry to the touch and almost definitely ready for lime washing. So when people talk about, oh, I've got to wait for weeks for the lime to do this one, that and the other, I sometimes feel that's a bit of an exaggeration. And let's remember, when these buildings were built, they were wet to the core. The mortar was wet, the entire wall was wet, but the whole fabric worked in such a way that that drying out was a gradual process, probably 6 months, probably a year, maybe even longer. And there's the link to the case study that you can see. I'm hoping that comes up when you get the presentation sent up. That was a local contractor. They had lime experience, but they weren't quite familiar with this sort of style, if that's what you could call it. And it's now had its 5th winter, no, more than that, 6th winter of being dry. So we're comfortable that has given good results. Much more simply and a little bit more recently, we supported a project in Dunbar, which essentially was a garden project, but they had probably 100 meters, no, 50 meters of boundary wall to address. And over a winter, in fact, this chunk of wall, this length of wall was rebuilt with a quicklime based mortar. And we played around with additives. We played around with wood ash as a pozzolan. We used different things, and it was a little unclear. I think probably what we got wrong here was the amount of pozzolan you need. So when people talk about crushed brick in a mix, it's not a sort of scattering like pepper on your chips. It's really perhaps 10% of the aggregate is your 10 or 20% is the crushed brick. So it's a significant amount. It's been a very slow set and not a fast carbonation. So if you drilled into the center of that wall today and put the testing stuff on it, the phenolphthalein, as people do, it would show that the carbonation hasn't really happened yet. And that's the feature that's coming out with newer quicklime based mortars, that they are quite slow to carbonate. That doesn't mean the mortar's not good. It doesn't mean the wall's going to fall down. It just means it's hard, it's stiff, it's firm, but it hasn't achieved the full strength that maybe the core of Stirling Castle has done. The interesting thing here was the contractor and the team, the labourers and everybody. They were pretty new to this, but they were up for learning, and some of them were returning to work and job seekers and things like that. And because they were starting new, they had no preconceptions about things, and in fact, I would suggest that they produce very good work in other areas and very competent line workers. So that was a really good story. And the case study slightly bigs up the people aspect of this project. You'll notice we used a pretty ugly concrete cope, gardens, paving slabs, because that's really what all the project could afford. But in fact, we felt that was very necessary to keep the rain off the top, because as I said, if you don't get that right, you haven't got a hope of anything else happening. So slightly related to that then, another very simple work on a stable block at Falkland up in Fife. And again, a contractor quite new to this, a lot of issues with the building that meant that the pointing and the masonry was suffering, not because it was defective as such, but because the conditions in which it was being asked to operate were just not right. So again, the basic 1 to 3 mixed and various options. We used crushed shell in that one, which seemed to work quite well, and some other factors, linseed oil painting and a bit of a sill adaptation and things like that. So that's the case study for that one. This was quite a big project. This is a property in care at Kinneal House near Bowness, and this was essentially a retaining wall with an orchard, the site of an orchard on the right, and then higher ground off to the left. it was beginning to move quite significantly. There were visitor safety issues. So we had scheduled monument consent for it to be dismantled. And I managed to sort of get into the project early enough to recommend that we approached it from a quicklime mortars point of view, which is what happened. It was CL90 sharp quicklime 1:3, and again large amounts of crushed shell added in as part of the aggregate, which seemed to help the setting. The work was between sort of March and August, and went well. And this picture shows us just at the end, with the top sort of leveled off more or less, waiting for the cope. And this project went really well, pretty much until that moment. And then we had delays with the cope. The quarry, as quite often happens, wasn't able to get the material through quick enough. We then had a very wet autumn, and this was the wall was wrapped up with about as much plastic as you could possibly hope to find, completely, which was the wrong approach, because in fact it stayed wrapped up in a plastic bag. It sweated, the tarpaulin was full of holes, so a lot of water got in, and basically what had started off with a very good initial set never got any further than that. In fact, it got wetter, and then the following January, February, March, we had ice and snow, and that gave, well, it just didn't quite ruin it, but certainly the surface of that wall, which was looking really nice, spalling and soft mush behind, particularly at the top, where of course the water just soaked into the top few inches, top 6 inches of it all, which was a real shame. And that was partly my fault, because I wasn't on everyone enough. I didn't really get the protection right. What this needed was a sloped hat just on the top that would run the water off to one side and allow the air to move freely around the vertical faces, allowing drying, carbonation, and all the things that we need to happen. And instead it sweated under its plastic bag with the frost and everything else until March, when we took it off and went, oh dear. So the outcome there is getting the cope right, because if we'd had the cope right on it, a lot of the protection issues would have been taken away, and the autumn and the early winter, which was perfectly dry, would have perhaps got it past that danger point of early curing. But we wrote about it, and I hope we were honest enough so that others can learn. But it survived that fine. The wall is structurally sound. There's a bit more pitting on the surface of the mortar than you might like to have seen after all that work, but I think in the scheme of things, the wall is still a good wall. It's doing its job, and it's doing what it should do. And a big benefit here was that we introduced a large number of HES labour and squads to this. So we cycled people through to get them used to it, and they like building it. It was, it's good material to handle and use, and gave something that we could feel was genuinely authentic. Quite a sort of normal piece of work, the gable end of a small cottage. The picture's not great, but I'm trying to show you that this was just the gable end, and this is showing now repairing the render the following spring, because as I've said, if you don't get your detailing right on the skew copes, you'll get damp, particularly at the bottom here. If you have damp mortar over a winter, it'll gradually get burst by the frost, as would any other mortar, cement, lime, or indeed NHL, anything else. So strength in itself is not always a benefit. What I should also point out, as part of the remedial work here, we put slate slips sticking out down just in the bedding mortar underneath the skew cope, which worked very well. And then we got the roan going full distance underneath the end of the skew copes. So small little differences small little adjustments made a big difference. So again, detailing, and if you get that right, a lot could be done. The previous conditions are things that you must have met all the time with cottages and smaller buildings. A decayed chimney and very friable damp masonry on the top, not helped by the presence of flue gases and other things. So a little bit conscious of time, so I'm just going to have to perhaps skip forward now. This is a building in Stromness. This is an interesting one, quite a big refurbishment in the 90s. And then later on, up here started to really suffer. And I was wanting to be quite aggressive in some new detailing here, and the local authority were very keen that they preserved this quite subtle, not quite crow step detail, but local detail, which is around, often later covered in concrete. And that was redone with a quicklime base mix, but with a good, respectful amount of NHL in it. That seems to have delivered good results. This was an art gallery, so when the water started coming in on the gable end, they were particularly good. And again, this was a local contractor who needed a bit of hand holding just to get them on the right path. Once we'd done that, I think it worked quite well, and they were pretty positive about the material in the right context. But I would always hold that this building is going to be vulnerable because there's not much drip detailing there at all. Some quite wide recessed joints there, which perhaps we wouldn't treat in that way now. So there is a vulnerability remaining in that one. Crawford John, this is an interesting story where it was a category B listed former church. This had pretty much everything thrown at it, including water repellents, silicons, and pretty much everything else. Quite a few detailing shortcomings which we addressed, led under the cope, reconfigured the louvres on the bell cot there. Quite a lot of lead used, which I think in moderation is fine. But the raking out of the old mortar didn't go back deep enough. So the new mortar, however traditional and good it was, didn't really cure the problem entirely. And my feeling is there might be a limit to how much mortar can deal with water. And this church was lime washed in the past, and coming back to Sandhar, I'm of a fairly strong view that actually it was the lime wash that saved us at Sandhar, because it caught all the small capillaries that will happen. And on this building, because of a desire to keep looking at rubble or coursed rubble, we weren't able to apply that, and it might be that that is the missing ingredient for very exposed buildings, because that's, after all, how it was originally configured when first built. So some thinking there, possibly. Right, just very quickly then, building 4 down in Dunbar, total ruin, and again, a traditional mortar used in its reinstatement. This was a sort of reverse entropy project, just working backwards in the decay process, like for like, completely blind to future service needs, because it was only going to ever be a bothy at this stage. And that worked very well indeed with a very standard mix. This was the same folk who'd done the boundary walls 2 years earlier, so we'd kind of moved on. I haven't yet written that project up, so I'm afraid I can't offer any further reading. That's how it looked as we got the roof back up, and that large chimney was rebuilt between January and March 2 years ago in quite cool conditions, and in fact with just sensible, careful use. That has not moved one single bit, and the lime wash is still looking pretty good. Note a reasonably good drip on the reinstated chimney head there. Right, St Andrews, very similar example. This was slightly testing the envelope to see how lime wash does in an exposed maritime climate. This is a bit of a mixed bag, this one. Previous interventions from the 90s hadn't really worked. A very hard NHL. It didn't look good. So this has got different areas of lime wash on it, with linseed oil made with seawater and different washes. So we're going to go back to this and have another look and see how we get on with longer term durability tests. It looks pretty good for now, but it's not quite so cheerful now, 2 years later. So work in progress on that one. And then finally, just lime burning itself and looking at what's the realistic options for burning one's own lime for specific projects. So here's a volunteer at, on the island of Lismore, where we did a trial burn and a few other things. Probably a feedville hydraulic lime. Lismore lime was exported all over the west of Scotland up until the late 19th century. So it would have been the mortar or the binder of choice, probably. Shipped by sea all over the west of Scotland. So we'll see. And interested in getting some lime burning done at HES sites, maybe to use in our repairs. And lockdown gave the opportunity for a bit of mud pie work, as you can quite literally see there. But I do have to freely admit that even when you have the ratios the same, the nature of modern quicklime seems to give us a denser, harder mixture, which is more sort of hydraulic, and more like a hydraulic lime in its performance. So it's not as capillary active. The lump on the right hand side there, that's a historic mortar, and the suction when you put the different samples in the water is very different to the older sample. You can almost hear it going, almost hear it taking in, which shows how capillary active it is. It's capillary active going in, it's very good at dispersing it too. Yet some of these samples didn't quite have that property. So I really need to wind up. So lots of monitoring work, further trials. I've got 2 PhDs on one on internal plaster and one on external lime coatings. This is essentially the author of technical paper 31, and we've got technical paper 33 pointing, about to come out. Hygrothermal properties, for those of you who do modelling, WFI, we need numbers for Scottish materials, and TP34 will give you numbers for some Scottish materials, some sandstones and some limes. We're working with Historic England, CADU, and Department of Environment in Northern Ireland on this very topic, and we've got a few trials at Tayport Harbour and then lime burning. So I think I really must stop because I've run on far too much, and very happy to take questions in the little time that remains.
Thanks, Roger. That was super interesting. We do actually have a couple of questions, so I just start reading them out to you. From Elsbeth, what's the best pointing detail? Flush, raked, also maximum joint thickness?
No, very good question. So here I sort of fell into the trap of obsessing about the material, but actually, as you say, you know, we've got to put it on a wall, and how's that going to look? I'm increasingly of the opinion that recess pointing is a later style, and the evidence from technical paper 31 and 33, which hasn't yet been published, slightly supports that. So my feeling for most traditional buildings, particularly if you can find evidence hidden under the eaves somewhere, is that most of it would appear to be flush. And your joint thickness in terms of the use of pinnings and getting your contractor to try and minimize the amount of mortar used, I would say that sort of anything more than 20, some sort of piece of stone squashed in there. The more you can control the shrinkage and the less cracking you'll get, which is particularly necessary. So that's probably a very quick answer, but in fact, there's a whole world there. And what I should do is introduce technical paper 33 to you all when it comes out, probably in a few months. Sorry, what was the second question after that? Next one then, probably.
Yeah, next question from Esther. How was the concrete cope secured to the wall? Traditional mortar? I think that's going back to the garden wall in Dunbar.
Ah, yes. Yeah, so that really ugly concrete slab, but cheap as chips. I mean, we were just given them by a contractor. They were laying down on the top, they were bedded down, and the joint was pointed up with a hydraulic mix because we needed a good hard joint between them. But they're just bedded on the normal stuff, normal mortar.
Okay, thank you. Next question from Elsbeth. if drilling through render to fix a fitting, say CCTV, then how should edge be drilled? Hole be finished, sealed? Question mark.
Just say it again.
So trying to paraphrase, if you are drilling through render to fix a fitting, for example, camera, how should the edge be drilled? How should the hole be finished or sealed?
Ah, right. Okay. So
Sorry.
let's say you've got a satellite dish going up or something like that, and the fella turns up and just blasts a hole. I think probably I wouldn't get overly bothered about that in the first instance, but maybe a little daub of just a bit of hydraulic lime putty, just smear it in just before you close up. So as you wind up the fixing to draw it in tight, maybe a plug of hydraulic lime just smeared around the fixing, and maybe if you set the fastening, the base plate, off the mortar with a plastic washer to give it sort of 5 mil off the plane of the wall.
Okay, thank you. Next question from Tibor. Are there any indicators within existing masonry walls that can help with specifying mortar or lime wash? I know to always consult with the stonemasons, but it would be nice to know if there are any small things I should look out for.
No, good question, because quite often we look at mortars on the surface of a wall, which of course is the degraded remains of something, and it often gets sent off for analysis and sometimes comes back with a much weaker spec than one should have. It depends if you're going to lime wash it or not. Aggregate does affect the color of the finished mortar, and in my sort of stumbling about, I've had some quite big differences in color, from a sort of dead grey to a lovely cream, and even a sort of light pink, depending on. So I think get a feeling for the aggregate of the masonry you have, and then the local sand in adjacent riverbeds, because that's telling you what the local geology is giving you for sand. You may see fragments of coal or charcoal from how the lime was burnt, and occasionally there's some unburnt or late burnt particles in there, and you can mimic that a little bit by putting in fragments of gone off hydraulic lime, just to give a few white specks in it if you're really going to try and, but that's perhaps getting a bit carried away. I wouldn't feel you have to study too much. What I'd suggest you do though is look on the surface of the masonry to get a feeling for how they covered the stone. Was it a full covering, a partial covering? Is the lime wash left on the stone? So maybe less on the mortar itself and a bit more what's surviving on the stone of the building, particularly around the back, where maybe it didn't get taken off in the 60s, or has survived in a very sheltered area, because that's perhaps your real sort of inspiration. And that's what technical paper 33 is trying to labor and demonstrate. Look around the back, look where somebody hasn't been with their chisel, and you'll get a true picture of perhaps what the building, how it was finished.
All right, that's interesting. I've got 2 more questions, so I'll just quickly read them out. One from Jim. Under what circumstances would you use an NHL mix?
NHL definitely has a place, and certainly anything below ground which will stay vaguely damp or wet, it's a fairly obvious one, because it's never going to dry. Maybe it's the edge of a burn, or even foundations which stay frankly below ground, and they're always going to be moist to a degree. Haunching of chimney cans, people use it for skew copes, where you need that hardness. Quite frankly, you need a bit of strength, because a skew cope is going to get rain on it all the time, and it's not quite a flat surface, but very close. So I think NHLs have plenty of space and opportunity, but perhaps not as the dominant feature in a render or a point, because you don't need that. The vertical surface should not be soaking wet. It should be a mechanism to exchange water liquid and water vapor as opposed to a hard solid barrier.
Okay, thank you. And the last question from Jason, what bearing does the type or source of sand have on the end color of lime mortar?
I've sort of slightly covered it, but more than you think. So, and again, it depends on how you finish the building. Obviously at Sandhar, it didn't really matter, but certainly an old red sandstone, such as in the borders, you'll get quite a pinky hue to your mortar. Glasgow sands from the buff sandstones will give you creamy white, and some sand, depending, is actually grey and just looks really horrid until it's weathered back a bit, and then maybe the particles show a bit differently. So to answer your question, more than you might think, even when you have a pretty strong lime mix. So, and if you have a mix that comes out bright white, it's probably dried, not carbonated. So if you see bright, strong white mortars shouting at you in the street as you walk past, it's either white cement or it's gone off too quickly. So generally you should get modest hues of cream or grey or pink. Thank you,
Roger. As always, you've been very generous with your knowledge and your time, so thanks again for that. And I've already put the links into the chat, but I'd also email them out to everybody afterwards, right, so they can go onto your website.
And I've actually managed to completely fail to give you a link to the HES short guide online mortars. It is quite general, but it's perhaps actually quite a nice introduction. So it's I've actually even forgotten the number for it, but if you go to the short guide section on the website, I'll pass the link on actually, because I think it's quite important, yes, because it gives you a nice introduction, even if it maybe doesn't go into quite the detail that I covered today.
Yeah, okay, perfect. If you do that, and then I'll email it to everybody afterwards. And
I'll take a tap for forgetting it.
Thanks again, Roger. And just to let you know, our next event is on the 19th of May, and it will cover public procurement with Brody's. Thanks again. Bye.